Hi, this is Sean.
This is Tim.
We're here to talk about two equations that deal with linear functions, essentially looking at point-slope form. We're given the points, and first they want us to write an equation of this line that passes through the 2 points in slope-intercept form. And I guess as a reminder, we should say, all right, slope-intercept form, of course, that's just y equals mx plus b. This is the formula they're talking about. Oops. And they're saying that you want to write an equation where m is your slope, right? B is your y-intercept, and y and x remain as variables. Do you want to add anything to that, Tim, about this formula right here, about what it means, or?
Nope, just m and b.
M and b, right? Yeah, m is our slope, and okay, and then and b is our y-intercept. Now, you might know that already, right? When you're solving this, but something usually is tripping students up when they solve these. So we'll work through this. We'll try to break this down logically so that for future problems we are feeling confident. So we know the 2 points, and essentially, I guess what I would do is the first thing is to find the slope, right? And then from that find the y-intercept. And that's generally my approach. Go for the slope, then go for the intercept. So how would you find the slope here, Tim, of when you're given these 2 points? What do we do?
We know that the slope is the change of y over the change of x.
Okay. Yeah, and this should be x, right?
Right.
I'll fix that.
And
Go ahead.
we can just plug them in from the points that we know. So y2 and y1 are 8 and 4 respectively.
So you're assigning this as 2 and 1, right?
Right.
In that order, okay. And could we reverse that if we wanted to?
No.
No.
If we could, but we would also have to reverse it for the bottom.
Okay, so if we start with this point, and that's the first point, then the corresponding point here needs to also be the second point.
Right.
So first, second, okay. So 8 minus 4, and then what?
And then -5 minus 7.
Okay, and what do we get?
And we get 4 over -12.
I agree, and -12. And I would reduce this down to -1/3, and that's our slope. And if you think about the formula, I guess, at this point, just saying logically, all right, we know the slope now, and we actually do know y and x for certain points, right? The y's and x's up here, and these points are referring to these variables right here at certain locations. So I think the logic for me now, Tim, is to pick one point. I'm going to choose this one to avoid the negative, plug it in, and solve for the only remaining variable, which at this point is the y-intercept. Is that how you're thinking about it as well?
Sounds good.
All right, so then we have y equals -1/3 x. That's what we have so far, plus b. So we have our slope, and now we're going to plug in 7 and 4 for the y and x value. So I get 4 equals -1/3 times 7 plus b. Is that right?
That's right.
Okay. So then I have my own technique here to get rid of this fraction and multiply everything by -3. And I get -12 is equal to 7 minus 3b. Of course, you don't need to solve it that way. But now what I would do, I don't know if you do this too, Tim, but I would actually add 3b, because I want to get rid of the negative to both sides, and add 12 to both sides. So kind of simultaneously balancing this equation out. And what happens here now, Tim? What's our next step?
Well, the -12 and the adding 12 cancels out. So on the left side, we just have 3b.
Okay.
And on the right side, 7 plus 12 is 19. And the -3b and +3b cancel each other out.
That's right. Now this division step, I think I would divide by 3 here. And really all that's going to happen is that this cancels out. And that might be an acceptable answer. But if you need to go further, I think that, okay, 3 goes into 19 6 full times. And there's one remainder, or 1/3. So it's just 6 and 1/3. Or 6.3 repeating. Now we're not done here because we just need to finish by writing the full slope-intercept form out. Again, slope-intercept form because it writes the slope and intercept. If I gave you the equation in this format, you know right away what the slope is, what the intercept is. And here we do. So we have y equals -1/3 x plus 6.3. Is that right? Okay, great. So that's the basic rundown of these questions. I mean, it's all going to pretty much have the same algorithm, at least it does for me, where you have the points, find the slope, and then find the intercept. Here, in the next problem, now they talk about something called point-slope form. Now, I guess we'll go straight at this problem, and then I'll talk about my way of solving it, which is a little bit different. Now, point-slope form is saying, okay, if you only know the point and the slope. Before we knew, if you look at this one, we were looking at the slope and the intercept. Now we're saying, okay, now you know a point and a slope. Which essentially is kind of the same thing, except before the point we knew was the y-intercept. Now we know any point, an arbitrary point, and they give it to us here. It's 2, -9, so that's our point. And I'll say one last thing here, Tim. I'll say that we have our point is equal to 2, -9, and we, like you said before, this is where the formula comes from in a sense that the slope equals delta y over delta x. And delta y is y2 minus y1, and delta x is x2 minus x1. That's what you said before, but here they're generalizing. So they're saying any y minus y1 over some x minus x1. And I'll just say I think the reason this is because the y1 and the x1, that's referring to the y1 and x1 here. That's what we know. We don't know any other y's or x's that are on this line. So we have enough now in this formula, right, where we know the slope and we know the point and we can plug it in. I think usually though, Tim, the formula is written like this. They multiply both sides by x minus x1, right? So you get x minus x1 equals m times y minus y1. I'm just, oops, equals, that's wrong. X minus x1 times m, right? Because we multiply this on both sides, and that equals, what does that equal, Tim?
Y minus y1.
Okay, so now with all of that background, we have a line that's perpendicular and a point. What do we do, Tim? How do we solve this one?
Well, in point-slope form, we know that x minus x1 times m is equal to y minus y1. And we have x1, y1, and m. x1 and y1 is just the point that we have, which is...
What was that? It was oh, there it is.
2, -9.
So x1 is 2 and y1 is -9, okay?
And m is 3, which we found above. So we can write this as x minus 2, in parentheses, times 3, is equal to y minus -9, or just y plus 9.
Okay, so here we have x minus 2 times 3 equals y plus 9, and that's the point-slope form. Here, just to be aware, because the formula says x minus x1, just because you see a -2 here, don't assume the point has a value of -2. In fact, that means it's positive. And the reverse is true here. You have to kind of think backwards, right? If you see a plus 9, and I said to you, what was the point used in this formula? In fact, you know that the value of y is -9, right? Because the formula originally says y minus something, and as you pointed out, in order to get a plus here, you'd have to subtract a negative. So as a quick side example, we'll kind of switch this around, and you tell me, Tim, if I wrote this out, right, x plus 2 times 3 equals y minus 9, what's the point now?
Well, now the point would be -2, +9.
Right, how'd you get that?
We know this because in the original equation it calls for x minus x1, but in the one that we have it's x plus 2. And to get a positive, that means that the original point would have to be a negative. We'd be subtracting a negative number to get +2.
Right, and similar reasoning here, right? It's subtracting 9, so 9 must have been positive, the sign didn't reverse.
Right.
Sometimes they look for the connection though between point slope and the other one, slope intercept. It's all right here. Once you have this form, if you just distribute the 3, we get 3x minus 6 equals y plus 9, and then the last step is subtract 9 from both sides. This cancels out and you get 3x minus 15 equals y. This right here is the same answer but in slope intercept. So these two things are connected just by a few, I think, algebraic steps. I think students should be aware of that. A slope point versus slope intercept are right. They're right there with each other. They're connected. If they both give up the slope and a point, but here with slope intercept, the point you're able to focus on is the y-intercept, and here it's any arbitrary point. Thanks.